MES Marampally e-learning.
Very good morning to one and all. Today we are going to discuss the subject Software Engineering for MSc Computer Science 3rd semester. The topic is Software Development Lifecycle Model. So before going to that, I am introducing myself as Dr. Julie M. David, Assistant Professor, Department of Computer Applications. The Software Development Lifecycle Model. What is Software Lifecycle Model? A software lifecycle model is a descriptive and diagrammatic representation of the software lifecycle model. It represents all the activities required to make a software product transit through its lifecycle phases. And before discussing the topic software lifecycle model, what is software engineering? And the software engineering is a branch associated with development of software product using well-defined scientific principles, methods and procedures. The outcome of the software engineering is an efficient and reliable software products. For that, we are using this software engineering and we are selecting the software engineering as one of the major or main subjects in the computer science. And the lifecycle model represents all the activities required to make a software product transit through its lifecycle phases, and it also captures the order in which these activities are to be undertaken. In other words, a lifecycle model maps the different activities performed on a software product from its inception to retirement. Different lifecycle models may map the basic development activities to phases in different ways. Thus, no matter which lifecycle model is followed, the basic activities are included in all lifecycle models, though the activities may be carried out in different orders in different lifecycle models. During any lifecycle phase, more than one activity may also be carried out. And discuss the different lifecycle models available now. Many lifecycle models have been proposed so far. Each of them has some advantages as well as some disadvantages. A few important and commonly used lifecycle model are the classical waterfall model, iterative model, prototyping model, evolutionary model and spiral model, and discussing each one. The first one is classical waterfall model. The classical waterfall model is usually the most obvious way to develop the software. Though the classical waterfall model is elegant and obvious, it is not a practical model in the sense that it cannot be used in actual software development projects. Thus, this model can be considered to be theoretical way of developing software. But all other lifecycle models are essentially derived from the classical waterfall model. So, in order to be able to appreciate the other lifecycle model, it is necessary to learn the classical waterfall model. The classical waterfall model divides the lifecycle into different phases. The first one is feasibility study, and second one is requirement analysis, and third phase is design, fourth coding and testing and maintenance. And the first one is we will discuss each phases in detail. The first one is feasibility study. The main aim of the feasibility study is to determine whether it would be financially and technically feasible to develop the product. First, project managers or team leaders try to have a rough understanding of what is required to be done by visiting the client side, and they study different input data to the system and output data to produced by the system, and they study what kind of processing is needed to be done on this data, and they look at the various constraints on the behavior of the system. After they have an overall understanding of the problem, they investigate the different solutions that are possible. Then they examine each of the solutions in terms of what kind of resources required and what would be the cost of development and what would be the development time for each solutions. Based on this analysis, they pick up the best solutions and determine whether the solution is feasible financially and technically. They check whether the customer budget would meet the cost of the product and whether they have sufficient technical expertise in the area of development. And the second phase of the waterfall model is requirement analysis and specification. The aim of the requirement analysis and specification phase is to understand the exact requirement of the customer and to document them properly. This phase consists of two distinct activities, namely requirement gathering and analysis and requirement specifications. The goal of the requirement gathering activity is to collect all relevant information from the customer regarding the product to be developed, and this is done to clearly understand the customer requirements so that incomplete and inconsistencies are moved. The requirement analysis activity is begin by collecting all relevant data regarding the product to be developed from the users of the product and from the customer through interviews and discussions. For example, to perform the requirement analysis of a business accounting software required by an organization, the analyst might interview all the accountants of the organization to ascertain their requirements. The data collected from such a group of users usually contains several contradictions and ambiguities, since each user typically has only a partial and incomplete view of the system. Therefore, it is necessary to identify all ambiguities and contradictions in the requirements and resolve them through further discussions with the customer. After all ambiguities, inconsistencies and incompleteness have been resolved and all the requirements properly understood, the requirement specification activity can start. During this activity, the user requirements are systematically organized into a software requirement specification document. The customer requirements identified during the requirement gathering and analysis activity are organized into a SRS document. The important components of this document are functional requirements, non-functional requirements, and the goals of implementations. And the third phase is design. The goal of the design phase is to transform the requirements specified in the software requirement specification document into a structure that is suitable for implementation in some programming language. In technical terms, during the design phase, the software architecture is derived from the SRS document. Two distinctly different approaches are available. The first one is traditional design approach and the second one is object-oriented design approach. And the traditional design approach consists of two different activities. The first, a structured analysis of the requirement specification is carried out where the detailed structure of the problem is examined, and this is followed by a structured design activity. During the structured design, the result of the structured analysis are transformed into the software design. In the case of object-oriented design approach, the objects that occur in the problem domain and the solution domain are first identified, and the different relationship that exist among these objects are identified. The object structure is further refined to obtain the detailed design. And the next phase is coding and unit testing. The purpose of the coding phase of software development is to translate the software design into source code. Each component of the design is implemented as a program module. The end product of this phase is a set of program modules that have been individually tested. During this phase, each module is unit tested to determine the correct working of all the individual modules, and it involves testing each module in isolation, as this is the most efficient way to debug the errors identified this message. And the next one is integration and system testing. The integration of different modules is undertaken once they have been coded and unit tested. During the integration and testing phase, the modules are integrated in a planned manner. The different modules making up the software product are almost never integrated in one shot. Integration is normally carried out incrementally over a number of steps. During each integration step, the partially integrated system is tested and a set of previously planned modules are added to it. Finally, when all modules have been successfully integrated and tested, system test is carried out. And the system testing consists of three different kinds of testing activities. The first one is alpha testing, second one is beta testing, and third one is acceptance testing. What is alpha testing? It is the system testing performed by the development team. And second one is a beta testing. It is a system testing performed by the friendly set of customers. And third one is acceptance testing. It is a system testing performed by the customer himself after the product delivery to determine whether to accept or reject the delivered product. and the system testing is normally carried out in a planned manner. According to system test plan document, the system test plan identify all testing related activities that must be performed. And the last phase of the waterfall model is maintenance. It is a typical software product requires much more than the effort necessary to develop the product itself. Many studies carried out in the past confirm this and indicate that the relative effort of development of a typical software product to its maintenance effort is roughly in greater ratios, and it involves performing any one or more of the following activities such as the correcting the errors, improving the implementation of the systems and porting the software to work in a new environment. Okay. These are the different phases of the waterfall, classical waterfall model. And next we are going to the next life cycle model, that is iterative waterfall model or iterative models. And to overcome the major shortcomings of the waterfall model, we come up with the iterative waterfall model. Here we provide a feedback path for error correction and we detect it later in a phase. True, the errors are inevitable, but it is desirable to detect them in same phase in which they occur. If so, it can reduce the effort to correct debug. The advantage of this model is that there is working model of the system at a very early stage of development, which make it easier to find functional or design flaws. Finding issues at an early stage of development enables to take corrective measures in a limited budget, and the main disadvantage of this model is that it is applicable only to large and bulky software development project. That is why it is very hard to break a small software system into further small serviceable or increments or modules. And the third life cycle model is prototype model. In this case, for the implementation of this model, we are making a toy, that is a prototype like toy. It usually exhibits limited functional capabilities, low reliability and inefficient performance compared to the actual software. A prototype is usually built using several shortcuts. The shortcuts might involve using inefficient, inaccurate or dummy functions. The shortcut implementation of a function, for example, may produce the desired result by using a table lookup instead of performing the actual computations. A prototype usually turns out to be very crude version of the actual systems. And in these cases, we require some the requirements for the prototype model is that you should ask some question, that is how the screen might look like and how the user interface would behave and how the system would produce the outputs. And based on this, we can develop a prototype model that can be used when technical solutions are unclear to the development team. A developed prototype can help engineers to critically examine the technical issues associated with the product development. The major design decisions depends upon issues like response time of a hardware control or the efficiency of the sorting algorithm, etc. In such circumstances, a prototype may be best. And the next one is evolutionary model. It is called successive version model or incremented model. At first, a simple working model is built. Subsequently, it undergoes functional improvement and we keep on adding a new function till the desired system built. And it has so many applications, and the main advantages of this evolutionary model or incremental model is that the user gets a chance to experiment partially developed systems and reduce the error because the core modules get tested thoroughly. And the main disadvantages of this model is that it is very difficult to divide the problem into several versions that would be acceptable to the customer, which can be incrementally implemented and delivered. And the next model of life cycle is of software engineering is that the spiral model. It is very important one, and the diagrammatic representation is shown in the slide. The exact number of loops in the spiral is not fixed, and each loop of the spiral represent a phase of the software process. For example, the inner loop might be concerned with the feasibility study, and the next loop requirement specification, and next on with the design and so on. And each phase in this model is split into 4 sectors, and the activities carried out during each phase of this one is object identification and planning, alternate evolutions and product developments. Okay, we can divide this spiral model structure into 4 quadrants, and the first quadrant that is used for objective setting, and the second quadrant for risk assessment and reduction, and third quadrant for development and validations, and fourth quadrant for review and planning. And these are the different phases for the that is the spiral model. During the first quadrant, it is needed to identify the objectives of the phases and examine the risk associated with the objectives. In the second case is a detailed analysis is carried out for each identified project risk and steps are taken to reduce the risks. And in the case of third quadrant, develop and validate the next level of the product after resolving the identified risk. And the fourth quadrant, that is the review the result achieved so far with the customer and plan the next iteration around the spiral. And the last one is the Rad model. The Rad model means that is based on the prototyping and iterative development with no specific planning involved. The process of writing the software itself involves the planning required to develop the product, and it is focused on gathering the customer requirements through workshops or focus groups, yearly testing the prototypes by the customer using iterative concepts, reuse existing prototypes, continuous integrations and rapid delivery. And these are the concepts we discussed in this class. That is what are the different types of life cycle models available in the software engineering. Thank you.